Welcome. So in this lesson, we're going to be talking about combinations of transformations. So this is when we're applying more than one transformation to a particular graph. So let's begin by reading the first question here. It says, find the equation of the image of y equals the square root of x after a dilation of a factor of 2 from the x-axis, followed by a reflection in the x-axis, and then a translation of 5 units in the positive direction of the x-axis. So as you can see there, I've highlighted in 3 different colors, there are 3 different types of transformations which are being applied to our graph here. I also want to draw your attention to some very key words, and those are followed by and then. So as you can see, there is an order to the transformations that are being applied, and that's going to be very crucial as we go through this topic. Now, there are 2 ways of answering a question like this. One is the quick way and one is the long procedural way. Let's go through the quick way first. So I'm going to call this simply by inspection. So kind of just looking at the information that we've been given and quickly coming to an answer. We know that we're starting with the graph y equals the square root of x. Y equals the square root of x. Now, we're told that there is a dilation of a factor of 2 from the x-axis. Now, remember, when we're dilating from the x-axis, that means we times the entire graph by whatever the factor is. So in this case, it's going to be 2. We're also told that there is a reflection in the x-axis. Remember that when we're reflecting in the x-axis, we put a negative in front of the entire thing. So that means there's going to be a negative right there. Finally, we're told that there is a translation of 5 units in the positive direction of the x-axis, and we know what that's going to look like. I'm going to replace my x with x minus 5, and that means it's going to move 5 in the positive direction. So we have, just like that, found the answer to our question. That's what it's going to be. I now want to go through the long procedural way of answering this, and I'm going to call this by the method. All right, so let's come down and let's go. So remember, we start off by writing this and then this. So this is what we've been doing in previous lessons. So we're starting with our original point and then we're going to a new point. Then we rewrite it and we're going to specify as to what our new x position is going to be. Well, I know that I'm translating 5 units in the positive x direction. So that means x dash is going to be x plus 5. And I know that my new y position, well, y dash, I have a dilation of a factor of 2 from my x-axis. So remember, when you're dilating from the x-axis, that affects your y. So it's going to be 2y. And I also have a reflection in the x-axis, and that also affects my y. So it's going to be negative 2y. The next thing that I do, having done that, is create equations. So I know that this is going to be equal to x dash. X plus 5 is equal to x dash. And I know that negative 2y is going to be equal to y dash. Now what I'm going to do is I'm going to take these 2 equations and solve them for x and y. So to solve this for x, I'm going to minus 5 from this side, minus 5 from this side. And that means what I'm going to be left with is x is equal to x dash minus 5. And then on this side, what I want to do is get it so just y is by itself. And to do that, I'm going to divide this side by negative 2 and this side by negative 2. So that means what I'm going to be left with here is y is equal to negative y dash over 2. Those are 2 very important equations we have found because we're now going to put them into our original graph we were given. So into the y position, I'm going to put negative y dash over 2. And into the x position, I'm going to put x dash minus 5. The last step that we do here is we solve for y and we drop the dashes. So that means I'm going to multiply this side by negative 2, multiply this side by negative 2, and I'm going to get y is equal to negative 2 the square root of x minus 5. So I drop the dashes and I solved it for y, and as you can see, that is going to be my answer, and that is the same thing we got right here. I also want to show you what this actually looks like if we were to graph it. So if I was just to bring down Desmos here for a second, and as you can see there, I've already just sketched what we're starting with, and that is the square root of x. Let's now draw another graph here, the square root of x again, and apply the transformations we were told. So the first thing that we did was we had a dilation of a factor of 2 from the x-axis, and we know that that just means we put a 2 in front of the whole thing. And as you can see, it dilated away from the x-axis. We then have a reflection in the x-axis, and that means I put a negative in front of the whole thing. And as you can see, it reflected in the x-axis. And then the final thing we had to do was a translation of 5 units in the positive direction of the x-axis, and that means we're going to have a minus 5 there. And as you can see, it moved 5 that way. And just like that, we have our answer, and that's what it would look like. And that's what we got. So you can do that both by inspection and through the long procedural method. Okay, so let's now bring this back up and let's keep on going. Let's go through our next example here. And this example, similar to the one up here, has the dilation as being away from the x-axis. So I want to go through 2 examples in which we're dilating away from the x-axis, because I think they're important to go through. Okay, so let's give it a read. It says, find the equation of the image of y equals x squared under a dilation of a factor of a half from the x-axis, followed by a reflection in the y-axis, and then a translation of 2 units in the negative direction of the x-axis and 3 units in the negative direction of the y-axis. Perfect. So as I said before, we can do this the quick way and we can do this the long way. The quick way we'll just call by inspection. And what we're going to do is we're going to say, hey, we're starting with y is equal to x squared. If I have a dilation of a factor of a half from the x-axis, because I'm dilating from the x-axis, I know that it's just going to put a half in front of what I've already been given. If I have a reflection in the y-axis, what that means is in the x position right here, I'm going to be putting in negative x. Now, here's the important part. If I do that, what is negative x squared? Well, when I square a negative, it just becomes a positive, and I'm just going to end up with x squared. So it doesn't change. And that makes perfect sense when we think about what x squared looks like. It looks like that. If this is my y-axis, if I was to reflect this in my y-axis, nothing really is going to change, is it? Nothing will change. Nothing will change. So that's why it doesn't affect anything. But that's something that really will trick people when they're doing it by inspection. They'll want to put a negative in here somewhere, and that's where the long method can really be beneficial. Okay, let's keep on going. It says a translation of 2 units in the negative direction of the x-axis. So that means I'm going to get x plus 2 squared. And then 3 units in the negative direction of the y-axis. That means minus 3 here. So that right there is going to be our answer. Let me just highlight it. Okay, let's now go through the long procedural method of answering this question. So let's call this by the method. So we're going to start off by writing this, then this, then we'll keep on going. We're rewriting it, and I'm actually going to have to come back up here just to see what this is. So x dash is going to be, well, I have a reflection in my y-axis, so it's going to be negative x, and then I have a translation of 2 units in the negative x direction, that's going to be minus 2. And then my y dash, well, I have a dilation of a factor of half from my x-axis, so it's going to be a half y. And then I have 3 units in the negative y direction, so it's going to be minus 3 there. The next thing that I do is I create my 2 equations. So I know that this is going to be equal to x dash. So negative x minus 2 is equal to x dash. And half y minus 3 is equal to y dash. A half y minus 3 is equal to y dash. Now I'm just going to solve each of them for x and y. So this is going to be negative x is equal to x dash plus 2. X is equal to negative x dash minus 2. And then over here, what I'm going to end up with is half y equals y dash plus 3. Now here's the important part here. For this next step, I'm going to multiply this side by 2, and I'm going to multiply this side by 2 as well. But as you can see, I'm multiplying the entire side by 2. So that means I'm going to be left with y is equal to 2y dash plus 6. So I'm multiplying the entire side by 2. Okay, now that we've got these very 2 important things right here, and I might even highlight them because they're very important, I'm going to be substituting these into my original graph that I was given. And the original thing that I was given here was y is equal to x squared. So into the y position, I'm going to be putting this, 2y dash plus 6. And then into the x position, I'm going to be putting this, negative x dash minus 2 squared. Okay, the first thing I want to say here, and you don't have to write this down if you don't want to, but this right here, this is important. If I have negative x minus 2 squared, that's going to be the same thing as x plus 2 squared. And the reason for that is inside this right here, I could take out negative 1 as a factor. And then here I could have x plus 2 because I've taken that out. And then I could say this is going to be negative 1 squared, and this is going to be that squared, like that. And then negative 1 squared is just 1, so that just leaves me with this, which is just that. So that means I can come over here, and I can just say this is 2y plus 6 is equal to x plus 2 squared. And now it's just a matter of solving it for y. So it's going to be 2y is equal to x plus 2 squared minus 6. And we keep on going. I now, and this is important here, to get rid of this 2, I'm going to divide by 2, and then I'm going to divide this whole thing by 2 as well. So that means I'm going to be left with y is equal to a half x plus 2 squared. Then half of 6 is negative 3. And as you can see, that is what we have up here. Amazing. Let's now highlight that, because it's that amazing. And let's now kind of just go through what we've done on Desmos, just so you can get a picture of what's actually happening here. So let's bring Desmos back down here. So here it is right here. So there's the previous thing we did. And let's just begin by graphing x squared. So there is x squared. Now the first transformation we had to apply was a dilation of a factor of a half from the x-axis. So what that means is, and let me just draw it again and do it here, so that with this, so let me just put brackets around the whole thing, and then in front of it I'm going to put a half. So as you can see here, I have a dilation of a factor of a half from the x-axis. So that means it's getting closer to the x-axis. It's getting closer to the x-axis. So it's coming closer to the x-axis. Then I have a reflection in the y-axis. Now, if I reflect this in the y-axis, it's not going to change anything. And I can show you that. It's not going to change a thing. As you can see there, if I replace x with negative x, it's just the same. But this is where you have to be careful now, because the next transformation that is being applied is a translation of 2 units in the negative direction of the x-axis. So 2 units in the negative direction of the x-axis. So if I was to do that, where you think, well, I'm moving in the negative direction, so that means I'm going to plus 2 to it. But as you can see, it goes in the positive direction. And that's because you've got this negative here. Well, if I know that the negative doesn't really matter, I can just get rid of it. So that's where you've got to be careful when you're going through these questions. And if you are doing it by inspection, if you are going to do it through this method, you have to be ever so careful, because people are going to make the mistake of, hey, do I have to put a negative sum here because it's reflected in the y-axis? When you're not going to make that mistake if you do it by the method. You're far less likely to make that mistake. So you just have to be really on the ball if you are going to do the inspection method. You just have to be really on it. And then the last thing we had was 3 units in the negative y direction, which is just minus 3. And then I actually don't need these brackets here. That is going to be my answer. So as you can see, I have dilated a half from the x-axis. I have reflected in the y-axis, which did nothing. I then moved it 2 left and 2 down. And that's exactly what we got here. Okay, hopefully all of that has made sense and you feel comfortable with doing this. In the next video, we'll go through some more examples, but I just wanted to spend some time going through these. Okay, hopefully you found this useful.